So I am making this video because a new primitive was just released into MCP called Elicitations. And I've been super excited about this since I first heard about it coming into draft a little over a month ago. It just landed. You can see this is from protocol revision from June 18th, but it took another week or so for it to get into the various SDKs. So we just kind of got access to it last week. I've been really excited about this because I think it solves a couple of real problems we've been seeing in our early MCP testing that we're doing with our internal agents here at Elicitations. So let's jump into what this is, why I'm excited about it, and how we can use it. I'm kind of going to split this into two parts of what are elicitations and then some examples of where I think they can help right now. So to understand elicitations, you have to understand how the MCP tool flow works, because elicitations are part of tools. So the way tools work is you have your three different kind of users. You have your actual end user, you have the LLM, and then you have the MCP. And the MCP client and the LLM are kind of tightly coupled in this case. Most of the time, if you're using a library, you kind of feel like they're one and the same. But the way you can think about it here is the LLM is literally the model you're talking to. The MCP client is probably proxying or delegating to that model for you, but they do serve different purposes. So everything above this dotted line is kind of your initialization. When you first set up a call that involves an MCP server, your MCP client is going to make a call to that server to ask for its list of tools and their schemas. The MCP server is going to respond, and then the MCP client is going to provide that list of tools to the LLM. And it's going to do that probably at the exact same time that the user prompt is sent. They both typically get bundled up and sent over in one call. So after the LLM gets the user prompt from the user, it has the list of tools from the MCP client. It will make a tool selection if it wants to, and it will make that selection to the MCP client. It will include the name of the tool it wants to call and the arguments it would like to pass it. Then it is the client's responsibility to actually make that call to the server. The server gives back a response. The MCP client then, I have these split because the MCP client could modify the response in some way. It sends a response back to the LLM. Then the LLM uses that response along with all the other context it has to formulate its final answer to the user. So this is the standard tool flow. This is how tools work in MCP right now. So what does elicitations change? This is what's really cool about it. So elicitations show up right here after the tool call has been sent from the client to the server. And what they create is a way that the server can now request information. Let me go to a solid line. The server can request information not from the client, not from the LLM, but all the way back to the user. And then when the user responds to this, it jumps the whole way back up. It is a way for the MCP server to communicate directly to the user without being proxied through the LLM. And this is super, super powerful because whenever an LLM communicates with a tool, you don't actually have control over what it's sending. So you're victim to the obvious one is non-determinism. It doesn't always formulate responses in the same way. Sometimes the LLM just won't pass an argument. We experimented a lot with addresses actually, and even if you tell an LLM that an address needs a street address, a city, and a state, if the user just gives the city and state, we have examples now where the LLM will sometimes just make up a street address because LLMs are completely purpose-driven to solve the problem in front of them. And they will not always let pesky things like the actual arguments you want get in their way. Another really cool time when this could come up is if you have complex arguments or arguments that only apply in certain situations. This is another place where you don't want to have to make the LLM figure that out. So we can actually look at some examples of where I think this could be useful. So I set up an MCP client here that just uses an LLM. It's actually just going to call, it's going to use the OpenAI SDK to go through our light LLM proxy. And this is a pretty standard looking client. I have the elicitation handler minimized for now because we're not going to use it in the first example here. But what does this do? We set up our MCP client. our client talks to our server. This is just instantiated in memory. Normally, if you'd be doing this, you'd be passing like a script or a URL, but this is just running in memory because it's all local. And this follows pretty much exactly what you just saw in that first diagram. First thing that happens, get our list of tools. Second thing we do, send our tools along with our prompt to the LLM. Then this is in a while loop here because what's going to happen, and this is the completely standard flow, this is pretty much how it always works, is if we have content back, we'll give that to the user immediately. And if we have no tool calls, then we're done. Our call is complete. But if we do have tool calls, then we are going to grab those tool calls and send them from the client to the server along with the arguments that the LLM specified. We're going to add the result of that tool call back into our message context, our message history here, and then we're going to send it back to the LLM, and we're going to loop until the LLM has made all the tool calls it likes. Super straightforward flow, just going through that, so there's nothing hidden here. So we're going to look at what I've called MCP server simple, and this is the MCP server without any elicitations. And I have two examples here. I have an order search, and these are super simplified for the sake of this demo, but the examples themselves are real. These are real cases that we have seen right now. They're just simplified for the sake of making this easy to look at. So we have order search, which takes an order date and an order time. And then we have cancel order, which also takes an order ID, and then it lets the LLM know, make sure to confirm this is what the user wants. So these are running via Slack. So I'm just going to run them. I'm going to boot up Slack. And I can go over here and I can go ahead and talk to the LLM. So let's make our first question here. I would like to delete order ABC 123. So we're going to give it a second, and this is with no elicitations. And this time, okay, this is great. It actually is going to say if you confirm. So that's good. It confirmed. Now, so why do we need elicitations in this example? Well, this is pretty interesting. All right, so it canceled. That's what we know that the tool ran. I'm going to hop into my history real quick, and I'm going to show you my last conversation with it. Please cancel order ABC123. I'll help you cancel the order, but I want to confirm. And then it immediately canceled it. So through two examples here, we found out in one case it canceled it without asking. In the other case, it actually did prompt. Cancel the F45 right now. And here we go. So by a slightly different phrasing, we didn't get that confirmation step anymore. This is a perfect example of the non-determinism that we get in AI conversations. So I'll go ahead and I'm going to open up a new chat with it. And I'm just going to say, can you search for orders for tomorrow at noon? This is using our other tool, our order search tool. And it says, absolutely, it's going to help. And look at that. It initiated a search for orders scheduled tomorrow, February 21st, 2024 at noon. It has no idea that this was the wrong action. And we have seen this over and over, that sometimes even when you have the right system prompt and you give it that context, you still end up with this problem. So let's cancel that. And let's look at how we can improve both of these with elicitations. So I'm going to go from MCP server simple to my actual MCP server, and we'll look at the changes that elicitations creates. So we'll start with the simpler one. In cancel order now, we have the exact same arguments, but instead of prompting it, instead of trying to prompt the LLM to confirm, we elicit to the user, are you sure you'd like to confirm this? And we require getting back a confirmation. If that confirmation is an acceptance, we'll go forward with it. If it is not, we don't. Then if we want to look at our order search, how did this one change? Well, this one changed by literally adding in some actual logic to check, whether or not they're asking for something sane. So in this case, what we did is we just said, if the order they want is literally in the past, then let's elicit some information. So down here, we elicited with just a message. So that's just going to be a confirmation. Up here, we passed a data class called order schedule that actually asks for a date and time. One of the cool things about elicitations is they are strongly typed. They are the opposite of kind of these LLM arguments. We do not want vague kind of assumptions about what the user is passing in. We want strongly typed specific inputs. So in this case, if they pass in a date that is in the past, we're going to specifically prompt the user for a new date. We're not going to ask the LLM to fix it. We're going to go straight to the user. If we didn't, then we'll assume that the LLM actually did know the current date and it's moving forward successfully. So let's run this and see the difference we get in both tools. Okay, a little bit of a jump cut there because it turns out Slack has some pretty strict rate limits on how many conversation replies you can look up. It's only 1 per minute, which I very quickly exhausted. So I turned off the ability for this app to know history in the conversation. I think that's going to be totally fine for our examples, though. None of them need to actually view the history of the conversation. So let's go back to our original example, and we'll use the prompt that actually was able to get through and have the behavior we didn't want. So we can say delete order the F45 right now. Now this time, it's going to hit the elicitation. And the elicitation is going to bring us up actual buttons that the user has to interact with. Because you remember our diagram, we're not talking to the LLM anymore. We are interacting directly with the MCP server. So if I go ahead and say no, it's just not going to be canceled, and we're going to get that second message. The system seems to have detected that you may have changed your mind about canceling the order. It's correct. So let's try that again. 45, and I'm obviously just making up these order IDs. If anything that looks like one, it's satisfied. So this time we're going to say yes. And there we go. Now let's go back to our search example where we told it we would like to search for orders for tomorrow at noon. And we should have the same problem where it's originally going to search based on February of 2024. And excellent. So it asked us, it did detect that, and it said, please confirm your order date and time. So we're going to click provide information, and we're going to get this nice pop-up from Slack where we can select a new date. So we'll go ahead and say like the 15th at 2 p.m. Submit that, and we should get a response accordingly. Yep, there we go. 7:15 and a time of 1400 hours, which differs from the original search parameters. That is very true. To show how we wouldn't need that, we could also say something like, for reference, today is July 7th. Now this time, it should just work without the elicitation. Still got us with the elicitation. Wonder why. Oh, look at that. I said today is July 7th. Now, this is great. I put logging in here. It called order search with July 8th of 2024. So even though I said today is July 7th and it correctly searched July 8th, which at the time of this recording is tomorrow, it got the wrong year. So let's try that one more time and give it even more information. And this is just another great example of why it's nice to have a strongly typed input. And in this case, a strongly typed defensive input and everything's working. When everything's working, you don't need it, but it's a nice thing to check. It's a nice thing to have to verify. What did we hit? We hit the Slack rate limit again. That's okay. Oh, there we go. Excellent. Let's see if it goes through. Oh no, we hit the Slack rate limit. That's okay. We got through everything I wanted to demo right there. So I think that shows a a lot of the power here. The last thing I want to show is we had this minimized before, but this is literally the elicitation handler. This is what's happening on the client. So ignore a little bit of this. Some of this is just trying to get Slack to cooperate. Slack has a restriction where you can't submit a form without the user taking an action. So a lot of this is us navigating that. But what our elicitation handler, the important part here is we get a message, and that message is what we sent here. For example, please confirm your order date and time. And then we get a response type, which is a data class object, or it could be something simpler. It could just be a type, like string or an int. In this case, we used a data class. The protocol specifies that you can use a data class like this, but it must be a shallow data class, as in this is perfectly fine, but you couldn't nest another layer deeper with something like if you had order type and this was another data class that described order types. You can't go multiple levels, but a shallow data class works great. And then as we saw down here, you can also supply nothing as the typing. And in this case, it just assumes you're looking for a confirmation. And our MCP client, in this case, we can't see what it's returning, but it is returning an elicit response. If you just return data, the library we're using, FastMCP2, will automatically cast it. You can also return a cancel response or a rejected response. So that is all I have to say on these for now. I think this is another really exciting extra level to MCP. It's continuing to kind of knock down the problems those of us who are the early adopters, like we are at Elicitator, are running into. And I think this is going to be a really great addition for these situations where you have information that is critical. You have information that an LLM is likely to hallucinate. You have information that you just want a human in the loop for. Now there's an MCP pattern, an MCP primitive for those types of situations.